All right, let's talk about some of the highlights of the Chapter 6 review. First of all, on number 1, solving the sine of theta equals 0. When you think about how you're at 0 and 1 pi on the unit circle for sine of 0, you want to talk about what you add on to get to that point every time. You're only going to go 1 pi, and then another pi, and then another pi, and another pi. So you're going to have 0 plus or minus 1 pi n, not 2 pi n. You're not going all the way around. All right, let's do cosine of theta equals square root of 3 over 2. Again, on the unit circle, we're going to find where that happens, and it happens at pi sixths and, oh, my favorite spot, 11 pi sixths. All right, so this time, though, when we go from pi sixths, we do have to add an entire circle. So we're going to go all the way around, add 2 pi, and then again, so 2 pi n. Now for the 11 pi sixths, same thing. You're going to add an entire circle, so go all the way around, plus or minus 2 pi n. So when it says solve for real numbers, you need to make sure you either add on 1 pi n or 2 pi n, depending on where you're hitting. Okay, let's just talk about this first graph. I'm not going to go over all of them, I just can't, but this says graph 2 sine of 4 theta minus pi on 0 to 2 pi. So first of all, I'm just going to graph sine with an amplitude of 2, a period of 2 pi over 4, so pi halves. This is going to look a little bit funky. Now, to do one period, I'm just going to go very, very small between 0 and 2 pi. Now, that's what I would normally want you to graph me, but it does say to go all the way to 2 pi from 0, so I'm going to do this 4 more times. Remember, the k means that it happens 4 times as often, and there you have that. Now, we do need to shift this, a phase shift of positive pi over 4. It's positive because you need to do the opposite of that negative pi in the parentheses. So each of the points are going to get shifted to the right pi fourths, which is going to be very hard for me to show you with my stylus here, but just shift them over just approximately pi fourths. Oof, rough. Eeks. That's a ha. Ha! Try it again. Shift it over. Just that one's a little better. See how it gets shifted over? Just half of each of the little tick marks. You get the picture. Dot, dot, dot. All right, let's also, let's do number 7 really quickly as well. So negative cosine of theta plus pi thirds plus 2. So that means it has a vertical shift of 2, so the equilibrium goes to 2. We are going to be flipping it at some point. Period is still 2 pi, but it does have a phase shift of negative pi thirds. So I'm just going to graph cosine regularly. So get all my awesome points going. There we go. All right, and whoop, there's my cosine graph. I'm going to do the phase shift of negative pi thirds. I'm going to approximate this for time's sake. I don't want this to be too long for you. So I'm going to go negative. You know what? I think that in my, yep, I did. When I did this, I shifted it positive pi thirds. That's all right. This needs to actually have been shifted the other way, but we'll make this work when I talk about it. All right, so yeah, that's definitely shifted the wrong way. It needs to have been the other way, but that's all right. Because the major thing I wanted to talk about that you did incorrectly in your quiz was the flip. A lot of you shifted it and then you didn't flip it as well. So make sure you take all those points and flip them upside down. There you go. All right, so that's basically it, except it should be shifted the other way, to the left. All right, I want to talk about number 13 and how we might figure out what this equation is. I'm just going to chop off one period. See that one period is 1 pi, so I need to figure out what k would be. Since period is 2 pi over k, and I know that, well, basically, I need to get rid of the 2 from my 2 pi. I know that my actual k value is 2. Okay, just going to do one of the word problems for you. This physics problem is pretty cool though. The motion of a weight of a certain kind of spring can just be described as a trig function, which is true. At time 0, Carrie pushes the weight upward of 3 inches. Oh, not 2, 3. So that means we have an amplitude of 3. And it goes up and down or returns to its point 2 seconds later. Ta-da! So it has a period of 2. So we're going to write this. It's a cosine graph because it starts up because she pushed it up. Has an amplitude of 3. And then a period of, well, we have a period of 2, so what does k need to be? Just set up a little equation of 2 pi over k equals 2. Multiply by k divided by 2. K is going to be equal to pi. So there is your equation. To find the position at 15.5 seconds, put that in for x and calculate. All right, last one. I just want to talk about writing an equation. We have an amplitude of 5. It's a sine function, so it'll be 5 sine. Then I need to talk about my period, which is going to be 3 pi. So I'm going to set up a little equation here of 2 pi over k equals 3 pi. Multiply by k, divide by 3 pi. Pi's are going to cancel out. K is going to be 2/3 x. Oh, phase shift. Shoot. Doesn't look like it's there. Well, if we had a phase shift, we would put up a plus c, and then we could have solved that as negative c over k. And then the vertical shift just gets added on at the end. Ta-da! Thank you guys. Good luck.